Next law is Charles' law, according to which for a given mass of gas means number of moles are fixed. At constant pressure means pressure kept constant. Temperature is directly proportional to the volume, or mathematically it is represented as V is directly proportional to T. When we increase the temperature, volume of the gas also increases. It means, suppose this is the volume of the gas initially and at 0 degree Celsius. If we increase the temperature from 1 degree Celsius, then the volume of gas also increases. If we increase the temperature, volume of the gas also increases. This is the first definition of the Charles law, or in other words, volume at constant pressure, volume of the gas increases with every 1 degree rise in temperature, and it is equal to 1 by 273rd of the initial volume. Suppose the initial volume is V naught. For every 1 degree rise in temperature, the increase in volume is V naught by 273. Or we can write volume at 1 degree Celsius is equal to initial volume taken initially, plus volume increased by when we increase the temperature from 0 to 1 degree Celsius. It is V naught upon 273. This is the increase of volume when we increase the temperature from 0 to 1 degree Celsius. For every 1 degree rise in temperature, this amount of volume is increased in the gas. Hence, at temperature T, the final volume Vt is equal to V naught plus V naught upon 273 into T. Suppose we take this temperature is 273 degrees Celsius, then what will happen? If we put the value of temperature here, we get the final volume at 273, which is equal to V naught plus V naught upon 273 into 273, and by cancelling it we get 2V naught. It means at 273 degrees Celsius, the volume of the temperature is double the initial value. V naught is the initial value. At 273 degrees Celsius, the volume of the final volume of the gas doubles the initial volume. This is the case when we increase the temperature by 1 degree Celsius. If we decrease the temperature by 1 degree Celsius, then what happens? The same amount, that is V naught upon 273, decreases from the original volume, that is V naught. If we decrease the temperature, then volume also decreases, and the amount of decrease here is also same, that is V naught upon 273. Then we have Vt is equal to V naught plus V naught, here we take minus, it is minus because in this case it is decrease of the volume, V naught upon 273 into T. If we take this temperature at 273 or minus 273, then what will happen? Or you can write Vt is equal to V naught plus V naught upon 273 into minus 273. Here we take the temperature in minus, and by cancelling it we get V naught minus V naught, which is equal to 0. It is practically not possible. Volume of the gas is not 0, but it is a hypothetical or theoretical. When we take the temperature at minus 273 degrees Celsius, the volume of the gas becomes 0. And if we plot a graph between volume and temperature, here this point represents the some initial volume, and when we increase the temperature, volume of the gas also increases, and this solid line represents the increase in volume of the gas when we increase the temperature. And if we extrapolate this line to minus 273.16 degrees Celsius, then the volume of the gas here is 0, and this temperature is called absolute zero. The temperature at which volume of the gas is 0, then this temperature is called absolute zero. And in the next graph, if we plot a graph of different gases by keeping the pressure constant, there is a linear increase in volume when we increase the temperature. When we increase the temperature, volume also increases. These are the pressures P1, P2, P3 and P4. When we increase the temperature, volume of the gas also increases at a particular pressure, and in this way pressure P1 is less than pressure P2, which is less than P3, and so on. It means Charles' law in this graph shows that this is 0 degree Celsius, and this is, suppose this is the 273 degree Celsius. Here minus 2 73.16 degrees Celsius is considered as 0 Kelvin. And from this to 0 degrees Celsius, we have 273 Kelvin. We move from 273 steps and we reach to 273 Kelvin. And from this 273 0 degrees Celsius to 273 degrees Celsius, we, it means it doubles the value of 273. Here we observe the interpret the relationship between Kelvin and degree Celsius, which comes out to be Kelvin is equal to 273 plus degree Celsius. If we convert degree Celsius to Kelvin, then we have to add 273 to the degree Celsius. Next is significance of Charles' law. What is the importance of Charles' law? What is the application of Charles' law? Here the air expands on heating. When we heat the air, it expands. It means its density decreases because the molecules gain the kinetic energy and they move more faster as compared to the earlier. And hence the density of the density of the air decreases because the molecules move far apart from each other. Thus, the hot air is lighter than the atmospheric pressure. And this fact is made use of in filling hot air balloons, in which the density of the air decreases when we heat the air. This fact is used in filling the hot air balloons, which rise up for the meteorological observation.